Okay, this is Larry, W6WUH in California, and got a little bit on the Swan SS200 circa 1971. Not a particularly common radio, but the Swan's first in solid state efforts, and a very good one. Made right around the time that they were transitioning into cubic ownership. But this is called the SS200. It's made in three versions: a 15 watt, a 100 watt, and a 200 watt input version. The only difference is the 100 watt output and the 50 watt output versions, the SS100 and 200, have different linear amplifier bricks on the back of them, and the 15 watt version doesn't have that brick, but the radios are exactly the same. The brick, there's a little jumper plugs on the back, and you put the brick on the back, and you take the output from the 15 watt driver and plug the amplifier into it, the amplifier back into the jack on the back, and instantly you have a 50 or 100 watt output radio. This is actually capable of 150 watts output without any trouble at all, and you have to run the gain down so you don't overdrive your amplifier. So let's see, I've got this thing on. Let's just listening to a weak station on the East Coast.
Radio, November, KI6 radio.
Alright, KI6RRN, got 259 Logan, LOG, roger.
Thanks again, 59 California.
So this is California talking to Utah on 40 meters. You can see the
WPZ rotation, go ahead.
got an interesting noise blanker, works pretty well.
Alright, thanks. With Bravo 0 Alpha Lima, I got your Illinois. Please copy 59 Logan, LOG, roger. Thank you, Kilo 0 Bravo, QRZ.
So, got the usual features, plus got a pre-selector, which I like in a radio. S meter, you can use a remote via phone, work split. 2 gear ratio dial, fast tuning, and vernier. Pretty close to 1 kc readout on the dial. Concentric RF gain and
59 Logan, LOG, roger.
that's the RF gain. There's the RF gain. This is a matching power supply speaker over here. Of course, the radio is a 12 volt radio, will work without it, but it's nice to have that. So you can work normal, opposite sidebands, CW, 80 through 10 meters, no work bands, adjustable CW drive, there's the calibrator, Vox controls, mic gain, quarter-inch mic connector, pretty standard. Dial set for the calibrator. So it's not a lot of controls, but it works well. And you know, it's got the Vox and the calibrator and an adjustable drive, and that's all good. So here we've got one. Turn this thing off, don't need to listen to it. Here we've got one upside down on the bench. This one somebody had tried to add wiring to hook it up to a Metron amplifier with band switching. I cut that wiring out, but we'll just take the covers off and take a look at what's in here. Might have to put the camera down for a minute. That cover comes off. So here's the board here with the calibrator crystals and the Vox unit. And you can see printed circuit board. One little IC in there. It's all common components. And this thing let me put the camera down again for a minute. Here's the bottom of the circuit boards. So let's take a look at how the band switch works here, because it's kind of interesting. You can see there's a lever that goes across from this band switching arm, goes over here, vertical shaft to band switch the VFO. So let's watch that work. That's pretty clever, pretty nice. Phenolic switches, receiver front end here, and band switch for the, probably for the carrier oscillator and the low pass filters. Here's the bottom of the circuit board, so you can see there's a couple of old electrolytics in here, ceramic caps. You can see that they're glass boards, G10 glass circuit boards, which is good, and pretty common American kinds of components throughout. The coil forms are cardboard, they're not ceramic or anything fancy, but actually, look at those. Those are actually plastic or ceramic bodies with cardboard cores for the coils. Alright, let's turn this thing over. I'll stop the camera for a minute. We'll splice this together. Okay, this is the back of the SS200. What we're looking right here now is this removable, interchangeable final amplifier unit. And if you look on here, you can see it says linear amplifier in and out. So this radio without this amplifier is a 15-watt sideband transceiver, and it will have a little jumper that goes through here, because inside the radio is the band switched low pass filter, and that's why this loops in and out. So it's a 15-watt radio. There'd just be a jumper between the in and the out, and that would be it. And if you have one of the optional linear amplifiers like this one, then you'll either have a nominal 100-watt output or a nominal 50-watt output amplifier. As I said before, this thing easily puts out 150 watts CW carrier or PEP without getting hot. No big deal. Battery's about to go out. Alright, I had to plug in the camera to the power supply because battery was going out. I want to emphasize that this is my funky radio, and this one has been modified, and I haven't put it back to original, so it's got some non-standard features on it because this guy did try to modify it so it could work with a Metron amplifier. This fuse here, not original obviously. Here's the power connector for 12-volt power. Standard. There's a side tone level output if you're working CW, the S meter adjustment. There's the standard antenna connection, SO239. And here, this plug on the back will key an external relay. So I drive my SB200 with my good one, and I have a little relay that plugs in there that keys the SB200, and this goes positive 12 volts when you key it. It doesn't go to ground, and I don't know what this little tuning thing is here. I don't know. Look in the book. All right, let's look at the top of this thing. Okay, again, I want to emphasize this is not my good radio, so this one has been dicked with a little bit, but we'll look at the basic architecture here. And here's the pre-selector here, and I think this is probably the, well, I have to look in there to see what it is, but probably the receiver front end board. Here's the IF board with the crystal filter, sideband filter, back of the S meter. You know, you see goofy things that have been added in here, and you know, I don't know what's with this stupid card here, but here's the VFO calibration adjustments, and this little added circuit board, I don't know what this is, probably something to do with that Metron amplifier. My plan is just to go in and rip out anything that isn't original. I already ripped out a bunch of wires in the bottom that weren't original, and I'll turn my good one upside down and compare them, get out the manual, and we'll get it going. But anyway, so here's the top side of those G10 glass boards, and you can see the kind of components that are here. Here's one little Texas Instruments SS700 series IC, real standard, discrete transistors through here, and I'd have to look in the schematic to see what they are, but these are all common components. So the little electrolytic caps going to be standard values. All the ceramic caps are never going to give any trouble anyway. So pretty, you know, American components, no surface mount stuff, human-sized components, so should not too hard to service if you're a solid state guy, and even a tube guy like me can find his way through it. So there's the basic deal. There's the back side of the VFO selector. There's the back side of the pre-selector, S meter, yada yada. Saw the other controls on the bottom. Pretty straightforward. These were made 1971, 1972. Here you can see the serial number on this says 11714, which may decode into a manufacturing date, I don't know. And editing, let's see, give you a little closer look at the dial, and there's fast tuning. So 38, 50, 55, 60, 70, 80, 90. So those are 5 kc dial markers in there. So if we set this, so there's 10 kc. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So not exactly 1 kc. And on 40 meters, let's look at it, see what it looks like. So there's 10 kc, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's just about 1 kc per division, so it's pretty close. So anyway, that's what it looks like. Swan SS200. Let me see if I can get the manual out. So this is what they gave you. They said a preliminary operations manual for the Swan SS15, SS100, and SS200. And here we go. Swan Electronics, subsidiary of Cubic Corporation, Oceanside, California. So here's the date, 10/73. So that pretty much dates the radio, and I have 2 manuals in there, both say preliminary, and it's, you know, pretty much a standard manual. You can read as well as I can. SS15 provides power input of 15 watts. SS100 and 200 provide 100 watts and 200 watts PEP respectively, and I think that's input. Blah blah blah. 25 cases, crystal calibrator, Vox, yada yada yada. Provisions for WWV and external VFO. I don't know about the WWV part. Let's take a look. So this is where the meat is. 80 through 10 meters WWV, distortion 30 dB down, carrier suppression better than 50 dB, sidebands better than 60 dB, sideband suppression better than 50 dB. Operates in the 2-to-1 FWR, grid block keying, Vox, crystal lattice filter, 2.7 kc with a 1.7 shape factor. That's one of the reasons these things sound good, is because they've got a fairly wide crystal filter that you're transmitting through. So audio response flat from 300 to 3000, 4 watts output, less than 10% distortion. Half microvolt sensitivity for 10 dB signal to noise ratio. Image rejection minimum of minus 55 dB, better than minus 75 on 80 meters. VSWR protection. When the SWR goes to 3-to-1 or higher, then it shuts the power down by 20%. Standard SWR protection circuit for the final amplifier. Infinite VSWR protection. Power supply requirements, you know, typical 20 amps for the 100 watt version on CW, 6 amps sideband. 200 watts input PEP minimum on all bands. 200 watts DC input on CW. And the dimensions 12.5 by 6 by 10 1/4. And the 200, the heaviest one, 19 pounds. Just in case you got one and you need to wire up your power plug, here we go. 1 and 2 are a speaker. You do not ground the negative or the either side of the speaker. Do not ground it. Chassis ground, battery negative, pins 3 and 4, hot connection, 12, 14 volts, pins 5 and 6. So that's what's on that Cinch Jones plug on the battery on the back. Speakers provided, power supply, blah 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 blah. Anyway, do not use a speaker or speaker combination less than 4 ohms, and don't ground the damn speaker. Now let's just take a look at the schematic and the architecture here a little bit. Standard TR relay with tunable filters in the front end. Looks like a dual gate MOSFET for the RF amplifier for the receiver. Filter driver switch and noise blanker. What do we got here? S meter ALC circuits. Here's the 5.5 megahertz crystal filter. Where'd that go? There it is. There's the signal path. So that's the IF is 5.5 megahertz. First IF. These all look like dual gate MOSFETs to me. Product detector. Mute switch, data blata, and the audio amplifier. Nothing there. Here's the noise blanker. Pretty elaborate adjustable noise blanker with 3 transistors. Here's the VFO. More MOSFETs. And you can tell these are pretty standard numbers here. They're old, but they're all available. Here's a carrier oscillator. And audio amplifier, there's nothing there. Up here, here's the first audio. Ballast modulator with diodes. And that's pretty straightforward. So here's a, where is it? Standard Texas Instruments 7000 series IC, which is a transmitting mixer. Broadband driver. Pre-driver. Driver. And push-pull driver there. This typical stuff with toroid filters. Now this is where that 15 watt output comes out on the back of the panel, and it goes to one of these two linear amplifiers. This is the 200 watt one, which I have, which has looks like push-pull parallel four output transistors, and the 100 watt one just has one pair, and the 200 watt one has two pairs, otherwise identical. So, you know, comes in one end, goes out the other, and that's all. And then there's the low pass filter. So either the 15 watt driver runs straight into the low pass filter, or the 15 watt driver goes to one of these amplifiers, and that goes to the low pass filter, goes to the TR switching, and out to the antenna. And here's the ALC and so pretty straightforward, no big deal. So I think what we've got all in all is a pretty straightforward transistorized analog American-made sideband transceiver for 80 through 10 with good set of basic features. Pre-selector Vox calibrator, adjustable CW carrier level, 2-speed vernier tuning, good S meter and ALC, they're all adjustable side tone, capability to use a remote VFO and work either split or it won't work split band, but it'll certainly work split frequency. And since it doesn't have a RIT, if you do what I do and work vintage sideband where guys are not all on the same frequency, having remote VFO would allow you to track the other transmitting stations and leave your transmit frequency in one place. Thing requires a little bit of warm-up time, but after that doesn't seem to drift much. So I just turn it on a half an hour before I'm going to get on the net, and it pretty much stays where you put it, and sounds good. Lots and lots of power. Barefoot, more than 150 watts output. So you need to actually crank the gain down a little bit so you don't overdrive your amplifier. If you've got an amplifier that wants 90 or 100 watts drive, don't beat it up. But there it is, the Swan SS200, 1973. And this is a precursor to the MX100, which is quite a different radio. But a lot more features than an Atlas, for sure. And a nice, good, solid radio. I just have cleaned this one up, plugged it in, and used it here for years now without really having to do anything to it. So I'll take the oddball wiring and mods out of the other one, and I'm sure it will function well too.